Well, what we learned so far? Let us review. We start talking about trig functions and the behavior of trig functions. Okay. Trig functions. Well, recall that when we were dealt with the trig functions, we say that if your function is defined as y equals to a sine dx, or if it's written as y equals to a cosine dx, then we can define the period and also the amplitude for these two functions. The amplitude is equal to, well, here we have the absolute value of a, and the period is 2 pi over d. Very good. So in general, we can write sine and cosine curve and their translation as follow. So in general, if you have y equals to a sine bx minus a constant like c, and if you have the same for your cosine function, y is equal to a times cosine of bx minus c, these c constant cause the horizontal translations or shift. Why is that? Because you are changing your x values. So let's write this down here. The constant c creates horizontal translations or horizontal shifts. Let's take a look at a couple of examples. What are we talking about here? So let me pause the recording and open the Desmos for you. So what is it that you're doing right now? We know that the period of sine and cosine sine and cosine functions are in between 0 and 2 pi. Well, what are you going to do? You're going to take each of these two quantities, either for sine of a times sine of bx minus c, or a times cosine of bx minus c, and solve for x. bx minus c is equal to 0. Let's go back to algebra. Isolate x. So you're going to get bx equals to c, or x equals to c divided by b. Also, it can be equal to 2 pi. Am I right? So bx minus c can be equal to 2 pi. Or bx can be equal to 2 pi plus c, or x can be equal to 2 pi over b plus c over d. So what do we have here? It seems that our x is sandwiched between C over B and C over B plus 2 pi over B. Keep this in mind. The number C divided by B is the phase shift. C divided by B is called the phase shift. So we talked about the amplitude, we talked about the period, and also if you write the function sine and cosine in more general form, you have a number C divided by B, which is called the phase shift because it shifts the graph. Okay, let's write down the summary here and go over a couple of examples. So our summary, if we have y equals to a times sine of bx minus c, or if we have y equals to a times cosine of bx minus c, well, the amplitude is absolute value of a, and the phase shift is going to be c divided by b. So keep that in mind. Now let us go over a couple of examples to try to analyze the behavior of our sine and cosine functions. Example. Suppose I give you the following function. I give you y equals to a half sine of x minus pi over 3. And I ask you, well, to find the amplitude and the phase shift and x-intercept, or the points of intersection with x-axis. These are the questions that we're going to answer. Find the amplitude. Find the zeros of this function. Okay, very good. So amplitude and slash period, let's find both of them. Well, so first of all, the amplitude as we defined is the absolute value of a half. All right, so let's write this down here. The amplitude by definition is equal to absolute value of a half. It's a positive number, so you're going to get your a half back is equal to a half. Well, what is the period? The period of your function is just the period of sine, which is 2 pi. What is your phase line? So we need to compare the sine of x minus pi over 3 with bx minus c. Let's write this down here and go over it step by step. X minus pi over 3 is bx minus c. So the invisible number 1 is equal to your b, and c is equal to pi over 3. So by the definition of baseline, you have c divided by b. The baseline is c divided by b, but c is equal to pi over 3, and b is just 1, so the baseline is pi over 3. These are the information that we have from this function. Let us take a look at decimals quickly and see what is the behavior of this function. So our decimals says, hey, we have a half times sine of x minus pi over 3. Well, this is the behavior of your graph. This is the graph of the function. Okay, so what are the zeros? What's the definition of zero? Zeros are x-intercepts, the point of intersection of the graph with x-axis. Well, we'll take a look at this. All of these dots can continue this process to the right, to the left. These are all x-intercepts of your function. Okay, so how do I find them? Let's go back to the board. X-intercepts are zeros of any function. Any function. So if you have a function and I ask you to find the x-intercepts, you quickly say, hey, I just need to find the zeros. What do I mean by zeros? To find zeros, you're going to set your y equal to 0. Remember that is from algebra. To find x-intercepts, we set y equal to 0 and solve for x. So this is the method that we learned in algebra. Now let us continue. My function, a half sine x minus pi over 3 is equal to 0. Am I right? Very good. A half sine of x minus pi over 3 is equal to 0. So what's the meaning of that? A half is not 0, so it means that sine of x minus pi over 3 is equal to 0. So sine of x minus pi over 3 is equal to 0. So what's the meaning of that? It means that, well, x minus pi over 3. Recall that when we had sine equal to 0 in one period, let's just do the recall here. Recall that. On one period, which was 0 to 2 pi, the sine of x is 0 at which values? When sine of x is equal to 0 and when sine of x is equal to 0. So how do we solve this? There is a possibility that x is equal to 0. Sine x is also 0 if x is equal to 2 pi. All right, this is what we learned before from the sine function. In one period, 0 to 2 pi, the sine of x is 0 at 0 and also at 2 pi. So no matter what that is, it might be theta equal to 0, it might be t, any other variable is acceptable. So over one period, 0 to 2 pi, sine is 0 at two angles. One of them is 0 and the other one is 2 pi. Is that right? Do we have any other angle to work with? Yes, No, these are the only ones. We have another one. Very good. So we have another angle, which is pi. So sine becomes 0 at theta equal to 0, theta equals to pi, and theta equals to 2 pi. Now we are dealing with this guy, sine of x minus pi over 3. And we want to know what are the angles at which this function is equal to 0. Well, you might say that, hey, my very first guess is sine of theta must be equal to 0. So what are you going to do? You're going to take x minus pi over 3 and set it equal to 0. By solving that, x becomes pi over 3. So this is your very first value. This is the very first x-intercept. So at x equals to pi over 3, you're going to have the very first x-intercept. Let us take a look at the decimals. Step by step, we're going to find all of the algebra behind this. Sine of x minus pi over 3. And this guy goes in the parentheses here and here. Very good. So take a look at this. Your very first x-intercept is pi over 3. Guys, again, the behavior of this function is different from the behavior of sine of x. This is sine of x. Sine of x hits x-axis at the origin. But this function is shifted pi over 3 to the right-hand side. Pi over 3. So the very first x-intercept is going to be pi over 3. So what is the next x-intercept? The next x-intercept is going to be, here you have pi plus pi over 3. So your next is pi plus pi over 3. If you take the common denominator between these two, you get 3 pi over 3 plus pi over 3, which is 4 pi over 3. Then what's next? 2 pi. 2 pi plus pi over 3. So if you take the common denominator, you get 6 pi over 3 plus pi over 3, or 7 pi over 3. And you're going to continue this process, all right? You can go to the left-hand side as well. So take a look at your decimals. By looking at the decimals on the left-hand side, this is my sine function. This is my sine function. It hits x-axis at negative pi. Negative pi plus pi over 3 gives me negative 2 pi over 3. So negative pi plus pi over 3. This guy is negative 3 pi over 3 plus pi over 3, or negative 2 pi over 3. We can continue this process. Also, negative 2 pi plus pi over 3, which is negative 6 pi over 3 plus pi over 3, or negative 5 pi over 3. And it continues, everybody. We have infinitely many zeros for this function because it's not restricting the domain. The domain is negative infinity to positive infinity. So you continue this process. If the question doesn't restrict the domain, you have to continue writing the rest of these down or use a simplified compact version to represent the solution as, well, here you're going to have, let me write it here for you. As you can see, you have pi, 2 pi, then you have 3 pi, 4 pi. So you're going to have pi over 3 plus minus k pi, and k is an integer. Integer, remember that integers, z or I is the set of signed numbers. -2, -1, 0, 1, 2, 3, and so on. So you list some of the angles this way, or you write them in compact form, compact version. X is equal to pi over 3 plus minus k pi. As you can see, you have all of them here. If k is equal to 0, then you get pi over 3 back. If k is equal to 1, you get pi over 3 minus pi. Pi over 3 minus pi. If k is equal to -1, you get pi over 3 plus pi. Pi over 3 plus pi, and the rest of them. Perfect. Let us go over another example. So this is our next example. We have another function. Here you have y equals to, well, I have -3 times cosine of 2 pi x plus 4 pi. First, find the amplitude, find the period of this function, then find the phase line, then find the zeros for this function. Zeros. Very good. So let us find the amplitude first. Remember that when you're having your trig function, in general, if you write it as y equals to a times cosine of bx minus c, the amplitude is the absolute value of a, all right, it must be a positive number because it's halfway distance between the maximum value and minimum value. So here you have a -3 in front of your cosine. The amplitude becomes the absolute value of -3, which is +3. So this is my amplitude. Well, what is the period? The period, based on the definition, is equal to 2 pi over b. So let us find the period. It says the period is 2 pi over b. What is b? b is the coefficient of my x, am I right? Well, what is the coefficient of my x? The coefficient of my x is just 2 pi. Well, that is interesting. So my period becomes 2 pi divided by b. b is already 2 pi. So I get 2 pi divided by 2 pi, which is 1. So the period of this function is 1. Okay. What about the phase line? Remember that the phase line was defined as C divided by B. Okay, comparing these two, Guys, the sign in between bx and c must be a negative number, am I right? But here you have a positive number. So what's the meaning of that? It means that it was negative 4 pi. So it was originally written as negative times negative 4 pi. And this guy is your C. So C is negative 4 pi. So my phase line becomes C divided by B, negative 4 pi divided by B, 2 pi, which is negative 2. So I found all the basics for this trig function. My next step is to find the zeros. Let us take a look at the behavior of this graph. That's the important part. Visualizing the graph helps to understand what is going on. Very well. Let's take a look at that desmos. So first, graph your cosine function, because this is your base function, and all of those functions, the rest of them are translations of sine and cosine. Later on, you're going to work with tangent, cotangent. So for this function, you have negative 3 times cosine of 2 pi x plus 4 pi. Very good. This is the behavior of this function. Wow. See, the function behaves like this. So comparing cosine and this new function, take a look at your cosine function. This is my cosine function. It passes through x-axis at pi over 2 at just give me the intersection between them. That's fine. At pi over 2, at negative pi over 2, at 3 pi over 2, negative 3 pi over 2. But for this new function, wow, take a look at this. I have my first x coordinate at a fourth, and then I have negative a fourth and 0.75, negative 0.75, and so on. So I'm interested in finding all of these zeros for this function. This is the visualization. I can use Desmos and take a look at these zeros. But what is the algebra behind it? So how do I begin finding the zeros? Guys, in general, remember that cosine is 0, cosine of angle, whatever it is, cosine of theta, an angle, whatever it is equal to 0. One of the options that you have is that angle is equal to pi over 2. Am I right? So whatever you have, it doesn't matter which quantity it is. It is just one angle, it's just, a combination of different expressions. It doesn't matter. You take that and you set that equal to pi over 2. So take a look at your question. The question says, hey, I have cosine of this angle, 2 pi x plus 4 pi. So the very first option that you have is to take this and set it equals to pi over 2. So again, cosine of angle is equal to 0. The very first thing that we learned using the unit circle was that cosine at pi over 2 is 0. So let us write it here. Zeros. To find zeros for x intercepts, we need to find the angles that make cosine equal to 0. We know that cosine of pi over 2 is equal to 0. So set this guy equals to the cosine of 2 pi x plus 4 pi and solve for x. So it means that this quantity here must be equal to pi over 2. This is your quantity, so it equals to pi over 2. And solve for x. So 2 pi x plus 4 pi equals to pi over 2. First, subtract 4 pi from both sides. Minus 4 pi minus 4 pi. So 2 pi x is equal to pi over 2 minus 4 pi, or 2 pi x is equal to, if you take common denominator, you get pi over 2 minus 8 pi over 2, or 2 pi x is equal to negative 7 pi over 2, or if you cancel out pi and pi, x becomes negative 7 over 4. Wow, I found my first x-intercept at x equals to negative 7 over 4. The graph hits or crosses x-axis. Very good. Let's take a look at our Desmos. Let's check to see if our answer is correct. This is the graph of 2 pi x plus 4 pi. And let me just get rid of my cosine, and these are all my x-intercepts. Then continue this process. To find the rest of your x values. So let us plug in different angles. So far, again, just remember that to find zeros, let's rewrite this one more time. To find zeros, find zeros. Zeros or x-intercepts of cosine of an angle. We set cosine of theta equal to 0, and that angle theta must be starting, for example, at pi over 2. That angle might be negative pi over 2, 3 pi over 2, negative 3 pi over 2, and so on. Or theta is negative pi over 2, or theta is 3 pi over 2, or theta is negative 3 pi over 2. And you can continue this process. And eventually you can find a pattern and list all of the zeros. So theta is equal to pi over 2. What is theta? We define theta to be this expression here. This is my cosine of theta, am I right? So since theta is defined as 2 pi x plus 4 pi, we're going to set this quantity equal to pi over 2, negative pi over 2, 3 pi over 2, and negative 3 pi over 2, and solve for x. So let us begin. We're going to begin by this, just to review. We already solved this one. I'm going to just show you one more time. Here you have 2 pi x plus 4 pi equals to pi over 2. So 2 pi x is equal to pi over 2 minus 4 pi, or 2 pi x is equal to pi over 2 minus 8 pi over 2, or 2 pi x Just move this a little bit. For 2 pi x is equal to negative 7 pi over 2, or x is equal to negative 7 over 4. Now, I'm going to set this angle. This is my angle. This is how the angle is defined. 2 pi x plus 4 pi, let me set it equals to negative pi over 2. So if I set it equals to negative pi over 2, I have 2 pi x plus 4 pi equals to negative pi over 2. The same process. Subtract 4 pi from both sides, you get 2 pi x equals to negative pi over 2 minus 4 pi. So 2 pi x is equal to negative pi minus 8 pi divided by 2, or 2 pi x is equal to negative 9 pi over 2, or x is equal to negative 9 over 4. I found the second value, the second x value, that if I plug that in to this quantity, my cosine becomes 0. Now, what if this angle is equal to 3 pi over 2? See if you can find any pattern here. 2 pi x, this is my angle. This angle, theta, must be 3 pi over 2. So my cosine becomes 0. 2 pi x plus 4 pi equals to 3 pi over 2. So 2 pi x is equal to 3 pi over 2 minus 4 pi, or 2 pi x is equal to 3 pi minus 8 pi divided by 2, or 2 pi x is equal to negative 5 pi over 2, or x is negative 5 over 4. Wow. Okay. What else do I have? Negative 3 pi over 2. 2 pi x plus 4 pi is negative 3 pi over 2. So 2 pi x is negative 3 pi over 2 minus 4 pi. So 2 pi x becomes negative 3 pi minus 8 pi divided by 2. 2 pi x is negative 11 pi over 2, or x is negative 11 over 4. And you continue this process. Continue finding the rest of the angles that make cosine equal to 0. So since we have a cosine function, this is your theta. Your theta is defined as this crazy looking quantity. You take this quantity and you set it equals to these angles and solve for x to find the rest of the zeros. So as you can see, for cosine of theta, we set this guy equals to pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2, and the rest of the angles that make cosine equal to 0. So suppose I make this function to be different. If I, for example, were to work with sine, the whole story will be different. So if you have an example like this, if you have y equals to sine of 2 pi x plus 4 pi, and I ask you to find zeros, well, sine of theta is equal to 0 if theta is equal to 0, if theta is equal to pi, if theta is equal to negative pi, and so on. So you're going to take this theta and set it equal to 0, solve for x. Let's take a look at this. Here you get 2 pi x plus 4 pi equal to 0. So 2 pi x is negative 4 pi, or x is equal to negative 4 divided by 2, or negative 2. As you can see, the numbers are going to be different because your sine is different from cosine function. Cosine is 0 at different angles than the sine. So here, if I set theta equals to pi, I have 2 pi x plus 4 pi equals to pi, or 2 pi x equals to negative 3 pi, or x becomes negative 3 halves. That's interesting. If I use negative pi, 2 pi x plus 4 pi is negative pi. So 2 pi x becomes negative 5 pi, or x becomes negative 5 divided by 2. So as you can see, my x values will be different because my sign is different from cosine.